Okay, today we're going to talk about writing a proof. This is an algebraic proof, and the reason it's an algebraic proof is because you're going to be using algebra. There are other kinds of proofs, but in this class we're going to study the algebraic proof. An algebraic proof is typically a two-column proof, which means that you'll have a left side and have a right side. The left side is when you're going to do your algebra the way you would normally do it, and on the right side you're going to have properties. So for each step you do on the left, you have to write a property. So in this case, we're going to be asked to solve 2 parentheses x plus c parentheses equals 12, and we're going to actually make a proof to show what x actually is. So the first thing we're going to do is just rewrite the original, which is 2 parentheses x plus 3 is equal to 12. And we don't give a reason for the first one because that's what we're starting with. And so now we would solve it the way we normally solve it. First thing we're going to do is we're going to distribute. So we're going to write 2x plus 6 is equal to 12. And then here's where we write the reason. So how did we get from this step to this step? We use what's called the distributive property. So over here we're going to write distributive property. And that's more or less how this is going to go. You're going to just do your arithmetic as you would normally do it, solving this for x. But for each step you do, you have to name a property. And sometimes what we used to do on the left-hand side actually is going to take 2, 3, maybe even 4 steps, because the properties, you can only do what the property says you're allowed to do. And sometimes we skip steps when we actually solve these problems. So the next thing we're going to do over here is we want to subtract 6 from each side. This is a good example. Typically we would just write minus 6, and then we would say 2x is equal to 6. But in this case we actually have to write it all out. So we have 2x plus 6 minus 6 is equal to 12 minus 6. And again, that's to get the 6 by itself. And when I do something to both sides, it's called a property of equality. In this case, we're subtracting, so this is the subtraction property of equality. Now, the subtraction property of equality doesn't actually do any subtracting. It just says that we're allowed to write it to both sides. The next thing we want to do is combine like terms. We got 2 pair of terms here that are alike, so we're going to combine them both. So we got 2x plus, and 6 minus 6 is 0, and 12 minus 6 is 6. So this is called combining like terms, or combine like terms. Now this is a little different than when we would normally do it, because normally we would not write this plus 0, because we know that it isn't there. But because combining like terms simply says that we can add or subtract things together that are alike, we have to write it, because 6 minus 6 is 0. It doesn't really vanish. Our next line is going to say 2x is equal to 6, which is, of course, what we would normally get to. We actually would probably start right here and go right to 2x equals 6. But this is called the additive identity. So your reason here is additive identity. And the additive identity says that anything plus 0 is that same thing. So it just means that 0 can now vanish. The next thing we're going to do is we're going to actually divide both sides by 2, because we want to get rid of this 2. And since we do things to both sides, that's another property of equality. In this case, it's the division property of equality. And then what we're going to do is we're actually going to just reduce these fractions. So we have 2 over 2 and 6 over 2. We're going to call that 2 over 2 is 1, and 6 over 2 is 3, or 3 over 1. And we're going to call this simplify. We could also call it reducing fractions, but since that wasn't one of the properties we listed, we're going to use the word simplify here. And lastly, of course, 1x times x is simply x. So we can now write our traditional x equals 3. And this is called the multiplicative identity. Any number times 1 is that same number. So x times 1 is that same x. And our reason is multiplicative identity. And if you notice, from after our original, we had 1, 2, 3, 4, 5, 6, 7 changes. And I have listed 1, 2, 3, 4, 5, 6, 7 reasons. Each change requires a reason. The only one that will not is this very first line, because that's where we start. So after that, every change is going to require a reason. So make sure that if you have 6 changes on the left side or 7 changes on the left side, you have the same number on the right side. If you have questions, please make sure you ask.